Hi everyone. So this is Unit 5 Lesson 2, the last lesson in Unit 5, and we're going to look at how to solve quadratic equations. So learning goals here, by the end of this lesson you should be able to solve quadratic equations by factoring. So if you remember the factoring techniques from the last lesson, we're going to apply those to solve equations. We're going to use the quadratic formula to solve quadratic equations as well. Sometimes you can't factor them and you need to use this other method. And we're going to try to understand quadratic equations a bit more because there may be two solutions, there may be one solution, or there may be no solutions to quadratic equations. So we're going to try to understand why that is and how you know that. Like if you're doing the quadratic formula, how do you know if that's what happens? Okay, so quick terminology to begin. So remember that when we use the word expression in math, we're talking about a group of terms. So 4x squared plus 3x plus 5 is an expression, right? It's just a group of numbers multiplied, divided, added, subtracted together. So that's an expression. It becomes an equation if you add an equal sign and then you have something else on the other side of the equal sign. So expressions do not have equal signs, equations do. And that's going to become important because you're going to see both of these terms used. And it can be a little bit confusing when we say factor to solve quadratic equations and factor quadratic expressions. So when we are solving quadratic equations, we are finding out what x is. Because we have an equal sign, we can do that. If you're factoring quadratic expressions, you don't have an equal sign, and the best you can do is factor it. You can't find what x is. Okay? So, solving quadratic equations. This is one of the reasons why you learn factoring, because factoring can be used to do this. So suppose I have this equation, x squared plus 10x equals to negative 21. If you see it written this way and you've kind of forgotten about how to solve quadratic equations, or you maybe didn't know how to do it, you might be tempted to say, okay, great, the negative 21 is on this side, that's where I want it, right? If I have a linear equation, typically that's what I would do if I had just a 10x here. If the x squared wasn't there, let's delete it for a moment. If it was just 10x equals to negative 21, I divide both sides by 10, and I get x equals to negative 21 over 10. Perfect, right? So you might kind of be tempted to keep the negative 21 over here. But you're not going to get the answer doing that if you have a quadratic equation because you have an x squared and an x. And you can't isolate x when you have both of these terms. So you need to do something different. So what you're going to do is you're going to bring the negative 21 over to the same side as the 10x. And you're going to keep everything on one side. And since you move the 21 over to this side, you now have 0 here. So it'll look like that. X squared plus 10x plus 21 equals 0. If you have a quadratic equation, this is the form that you want to get it in if you're going to try to solve it. So this is not the final form that you want to get it into, but you certainly don't want it like this. So you want to get it into something like that. Because what you can now do is if you look on the left-hand side, you can factor this. And you can factor this using decomposition. Now, you might be looking at this, and if you already know it, you might be thinking, well, I can just factor this by the simple trinomial method. And again, if you know that, feel free. If I ask you to factor something by decomposition on a test or an exam, and you want to do it by simple trinomial, that method doesn't always work, but in this case it does. So if you want to use simple trinomial and you have the conditions right so that you can use it and you use it on a test or a quiz, I'm fine with that. So if you have to factor something like this and you want to use simple trinomial, feel free to do that on a test and a quiz. You won't lose any marks. Okay, but we're going to do decomposition because, again, we have limited amount of time and I don't want to overwhelm you with too many factoring techniques. So what we want to do then is you have a 1 there and a 21 there. So 1 times 21 is 21. So what we need to do then is find two numbers that multiply to give you 21 and add to give you this 10 here. So it turns out that those numbers are 7 and 3, right? 7 times 3 is 21, and 7 plus 3 is 10. So we're going to decompose this 10, break it up into a 7x plus 3x, and then we're going to group. So we'll group those two, and we'll group those two. And then what you have to do, remember, is factor each set of brackets individually. So here we have a common factor of x. X squared and 7x have a common factor of x, which I pull out, and this becomes x plus 7. Here I have a common factor of 3, so I pull the 3 out, so this becomes a 1, so it's just an x. and so that's 3x divided by 3, right? So divide 3 by 3, and that's a 1, and divide 21 by 3, and that's a 7, which is great because that's what we need, right? We need these two brackets to be the same. So then we can pull out the x plus 7 from both of these, and we are left with x plus 3. So we have x plus 7 times x plus 3 equals 0. So we have now factored the left-hand side. And this is going to allow us to answer the question. And to understand why that is, and to help you think about Unit 4, because you're going to have to use that on an exam soon, when you have the left side fully factored, you can relate it to this, a quadratic relation, right, where you have a y and an x and you can create a graph. So you have a 0 over here, but let's just imagine that there was a y there instead for the time being, because then you can graph it, and it will look like that. So that you have an x-intercept there and an x-intercept there, right? So if you have this graph, you have an x-intercept at negative 7 and an x-intercept at negative 3. So remember, on a graph, if you have x-intercepts, that means that y is equal to 0. That means you have this. So your x-intercepts are actually going to be useful here because the x-intercepts to this relation are actually the roots, which is the word that we use for solutions, the roots or solutions for this equation. So negative 7 and negative 3 turn out to be your answers. Okay? And if you remember back in that lesson again in Unit 4, the reason that's true is because you have factors, right? Because these brackets are multiplied together. That's why you do factoring, so that you can get everything multiplied together. It works because remember that it doesn't matter now what this bracket is if this bracket is 0. If this is 0, then you have 0 times something. Doesn't matter what the something is, the equation will be true. You'll have 0 on the right and 0 on the left. So you want to find out what makes this bracket 0, and then you want to find out what makes that bracket 0. So we take them apart individually. And you can probably just see that negative 7 makes this 0 and negative 3 makes that 0. So those are your two roots. Those are your two solutions, right? If I put negative 7 in here, I get negative 4 there, but that doesn't matter because 0 times negative 4 is just 0. And on the right-hand side, if I put in negative 3, I'm going to get positive 4 there, but again, that doesn't matter because 0 times positive 4 is also 0. Okay, so we have two solutions, or two roots as we call them, negative 7 and negative 3. Okay. You can have more examples about how to solve quadratic equations through factoring if you watch this video here, but I'm just going to give you the one for now. Okay, what if we want to solve quadratic equations using the quadratic formula? So you may have seen this before. The quadratic formula can always be used to solve quadratic equations. So if you're confused, if you're stuck, you can always do this. But we need to talk about what that quadratic formula is. Also, just so you're aware, you probably know this already, but when you're factoring polynomials, they don't always factor, right? These polynomial expressions don't always factor. And so you might kind of come up with a case where you actually can't factor, and you have to use the quadratic formula. So like we said, the quadratic formula always works. Factoring doesn't. So if you can't factor it, just go to this. So this is the quadratic formula right here, negative b plus or minus square root of b squared minus 4ac over 2a. And it's x equals to that. So in other words, if you want to find this x, it's equal to this thing. For the purposes of this class, this formula is going to seem like magic. I'm not going to tell you where it actually comes from because it involves knowing a technique called completing the square, which we're not going to have time to cover. But if you know that technique and you want to learn why is this the formula, that's right here. So this video here will prove to you that this is true. Basically, if you take the standard equation of a quadratic equation, right? Remember that every quadratic equation can be written in this form, back from Unit 4. If you take this standard form and complete the square on it, and then isolate for x, you will get this. Okay, so this is the formula. Let's use it. We need to plug this equation into the formula. So you have an x squared term, an x term, and a constant term that has no x on it. Everything is on the left-hand side. And so you have your a, you have your b, you have your c. So my a is the thing that goes with the x squared, so that's 3. My b is the thing that goes with the x, so that's 4. And my c is the thing that doesn't have an x, and it includes the negative. So it will be negative 5. So A is 3, B is 4, C is negative 5, and I'm going to plug them all in there. Okay, so we can see that. Now it's just simple math, right? Simple computation. So 4 squared is 16. Negative 4 times 3 is negative 12. Times negative 5 is positive 60. So we're going to get the answer as negative 4 plus or minus the square root of 76 over 6. And notice that there's a plus or minus here, which means that you actually have both. You have the plus and you have the minus. You have two answers. One of your answers is going to be with the plus, and one of your answers is going to be with the minus. And you don't need to convert them to a decimal. This form is more accurate, right? And it's an exact number because root 76. 76 is not a perfect square. It's irrational. So if you change this into a decimal, you're going to be rounding it. So if you leave it in this form, it's in its most accurate form. Yes, these solutions are ugly, but sometimes that's just the way it is. They are the correct solutions. Okay, so if you put this as your answer, you would get full marks for the question. I just want to mention, though, that if you put this as your answer in grade 11, you will not get full marks. So you might maybe have some awareness of this already, but you can actually simplify roots sometimes. And if you do that, you'll get this as your answer. If you don't know what I'm talking about, don't worry about it. But if you do know what I'm talking about, try it. You should get this. Okay, so quadratic formula, right? Pretty easy. Just sub in numbers. The last thing we're going to cover is the different kinds of cases that you can have when you get solutions with a quadratic equation. And these cases can apply whether you're factoring or whether you are using the formula. The last case doesn't really go with factoring, but the first case does. So some quadratic equations will have one root or no real roots. So in other words, the two quadratic equations we've looked at so far have both had two roots, right? They've had two intercepts if you graph them, and they have had two answers. So negative 7 makes this bracket 0, negative 3 makes this bracket 0, so both of those are your answers. But sometimes you're just going to have one answer. And you can see that this equation here actually just has one root. And that makes sense when you think about it, because you have x minus 1 times x minus 1. So for both brackets, it's only 1 that will make it 0. And you can also solve these algebraically. This you can actually just solve in a sort of almost like a linear equation, because everything is squared here. It's not like you have a separate x squared and an x. Everything is squared. So you can take the square root of both sides, and you're going to get 0 equals to x minus 1. And so therefore, x is just 1. So there's only one answer. X is equal to 1. Okay? So that's connected to this case, where you only have one x-intercept because the vertex is actually on your x-axis. So it's not touching at 2 points, it's just touching at 1. Okay? So it's fairly easy to pick out if you have your equation in this form. But what if you have an equation like this? This is not in that form. Now you can actually change this into that form. If you factor it, you can actually factor this one. But let's put it in the quadratic formula, see what happens, and you can then recognize this case if you use the formula. So we have an a value of 1, a b value of negative 4, a c value of 4. So we plug those in. And what you'll notice is 4 squared is 16. And then negative 4 times 1 times 4 is negative 16. So here I have 16 minus 16. I get a 0 under the square root. And that's what happens when you have only one solution. You'll have a 0 there. If there's a different number there, right, like imagine there was a 4 over there, and you take the square root of 4, you get 2, you now have negative 4 plus or minus 2. So in one of your answers, you'll have negative 4 plus 2, and in one of your answers, you'll have negative 4 minus 2. Those will both be different numbers for your numerator, so you'll have two different answers to that problem. But if there's a 0 here, the plus and minus doesn't matter, right? The square root of 0 is 0. Negative 4 plus 0 is negative 4. Negative 4 minus 0 is also negative 4. So you're only going to get one answer. And the way that you can recognize that is if you have a 0 underneath this square root, that's it. You have one answer. You're done. Okay, so you just need to find that answer then. So you get negative 4 over 2, and that simplifies to negative 2, and that's your only root. That's your only answer. Okay? Again, you could factor this. If you were to factor this, you would get x, well, that doesn't seem right. Yeah, you'd get x minus 2 squared. But then if that's the case, this should be positive 2. I see. There's a mistake here. This should be a positive 4. So your answer is actually just positive 2. So check it, right? Does positive 2 work? If you put 2 in there, 2 squared is 4, minus 4 times 2, so 4 minus 8 is negative 4 plus 4. So yeah, the answer actually is positive 2, not negative 2. The mistake I made there was I assumed that I didn't make the mistake there, but when you plug in negative 4 into b, so you get negative 4, that'll become a positive there. So just be careful. So yeah, you solve this and you get x equals to 2. And if you were to factor this, you're going to get x minus 2 all squared. So it'll look like this, except this will be a 2. So that will also solve to x equals 2 if you use factoring. All right. Last case. You can have quadratic equations that have no real roots. So what happens when you have a quadratic equation with no real roots? Well, what happens is you generate an equation that can't be solved algebraically, or at least can't be solved algebraically with what we've covered in the course so far. So suppose you have 0 equals x squared plus 1. This quadratic equation has no real roots. So let's try and solve it algebraically, because you don't have an x term here, right? You have an x squared but no x. So you don't have to worry about x squared and x being on one side. So if you bring this one over to the other side, you don't have to worry about the extra x over here. So you can actually do that. We'll take the square root of both sides, but when you do that, you're now taking the square root of a negative number. That's not so good, because if you take the square root of the negative number, on my calculator anyways, you're going to get an error. Some calculators will actually be able to do this, because there actually, believe it or not, is an answer to this. The square root of negative 1 is what we call an imaginary number. We give it the symbol I, but that's outside the scope of this class, so don't worry about that. If you get the square root of a negative number, then you will just say that there are no real roots. There are no real numbers that are solutions to this equation. And that's what it looks like on this graph, right? Because this is the case where the thing that makes this equation 0, well, if this was y equals x squared plus 1, that's what it would look like. And there is no place on this graph where y equals to 0. If you're interested, because it is kind of cool, the imaginary number answer does exist on a graph, but you have to see a graph in 3 dimensions to actually see that. But in any case, we're only working in 2, so the answer is there are no real solutions. Okay, so again, what we're going to do is look at a more complex case where it might not be so immediately obvious to you, something that you maybe can't graph right away, and so you don't see, oh, there's no x-intercept, so there's no solutions. What if you get something like this, where it's not obvious, maybe looking at it right away, if there are solutions or not, right? Are there 2 solutions, 1 solution, no solutions? We can't factor this, so we got to try and use a quadratic formula. So I have my A, I have my B, and I have my C. So I plug all of those into the quadratic formula, and you'll notice that what happens in this case is you get a negative number underneath the square root here too. And so that's how you know, based on the quadratic formula, if you have this case where there are no real solutions. So the second you see a negative number under that root, just write, we have a negative number under the square root, so there are no real roots. If you're kind of clever about this, or maybe you've seen this before, the way to test for the number of roots that you have, you can actually just use this part, because this is what determines if you have 2 roots, 1 root, or no roots, right? If this number is positive, then you can plus and minus it, and you'll have 2 roots. If this number is 0, then you'll have just 1 root, because you're plus or minusing 0, which doesn't change it. And if it's negative, you'll have no real roots, because then you can't take the square root and get a real number. So we call this the discriminant. We're not going to worry about that in this class. But if you want a shortcut, so to speak, just to see if there are or are not solutions or how many there are, you don't actually have to do this whole formula. Just do b squared minus 4ac. However, if you do discover that there is one solution or that there are two solutions, you will actually need to do the whole formula to actually find what those numbers are. So this little part in here can only tell you how many solutions you have. It can't actually tell you what the solutions are. So if you do have solutions, you actually have to use the entire formula to get them. Okay, so that's why I'm not really teaching this, again, because time is short, and yeah, it's kind of annoying, but you can actually get the answer by using the whole formula. You don't have to use just that little part in there. Okay, so that's all I've got to say about quadratic equations. You can solve them through factoring. You can solve them using the quadratic formula, and sometimes there will be two real roots, sometimes there'll be one real root, sometimes there'll be no real roots, and you can kind of understand why those situations happen when you look at graphs that are related to those equations by the quadratic relations that they're associated with, y equals x squared plus whatever. Okay, that's all I've got to say for now. Have a good day.